Alright everyone, welcome to today's tutorial. Today we're going to tackle this integral using a jaw dropping technique, so you can't afford to miss out, so stick around and watch to the end. At first, let's name this integral I. Of course we have an R here, which shows that the interval of this integral is a set of real numbers, which is from negative infinity to positive infinity. So I'm going to rewrite this integral using its interval. Now watch out for this transformation. When you have an integral from a to b, it is the same as the integral from c to b plus the integral from a to c. With this as a base, we can apply it in our own integral, taking c to be 0. Now I'm gonna split my integral using this transformation. Adding the second part. I'm much more interested in this second part of the integral, so let me bring it out. Now let's run some source code. Let x become negative x, so that the x becomes negative dx. Now I have my integral from 0 here. I have negative of negative infinity, so it's positive infinity. Then the remaining part of the integral. sine negative x divided by e plus cos negative x. Remember here to be negative dx, and then beneath it will be negative x. Remember that when a minus sign multiplies an integral, it changes its interval. So I'll use the negative sign here to interchange the interval of this integral. Now note that sine minus x is the same as minus sine x. And its arctangent. Is the same as this. Well, because x is an even function, these two can take good care of themselves. Haven't seen how we transform from this integral to this. Now check this out. These and these are actually the same. So I is equivalent to 2 times this integral. Now let's introduce the complex numbers. Note that arctan x is equivalent to 1 over 2i multiplying ln 1 plus ix all divided by 1 minus ix. Again, let's run some source code using this identity. Introducing the natural log. These two smoothly cancels out. Now I'm left with 1 over I multiplying my integral. Simplifying this complex structure, I have Alright, let's proceed. From the basics of complex numbers, we have that this is equivalent to e to the power of ix. And this e to the power of negative ix. Recall, from the subtraction law of logarithms, we have that ln a over b is equivalent to ln a minus ln b. Here comes its application. Now let me introduce a weird important step. Let me introduce a minus sign here. By reason of the minus sign, let me write this one first. Now let me introduce something. It's known as Frullani theorem. It states that when we have to integrate over the positive real numbers for a function that takes this form, the result then is the same as function infinity minus function 0 multiplying ln a over b How does this relate to our integral? Now let's take here to be function ax and here to be function bx. Now let's take our function x to be ln e plus e to the power of minus ix. Now if you compare this function and this integral, you find out that a, which is the coefficient of x in this part, is 1. And b, which is the coefficient of x here, is minus 1, since minus minus has to cancel out. Therefore, applying Frullani theorem in my integral, instead of inputting the integral, I'm now going to put the function infinity minus function 0. Then ln a over b. Let's proceed. e to the power of negative I infinity is 0. And remember, anything raised to the power of 0 is 1. So what's next? This. Remember, 1 over minus 1 is the same as minus 1. Time for more simplification. Now I'm gonna bring in the subtraction law of logarithm. Yeah, a plus 0 is same as 0. Now let's take this into consideration. Remember from Euler's identity that e to the power of I pi is minus 1. So its logarithm, on the other hand, is this. Applying the power law of logarithm, I have, and this is the same as I pi. Doing my substitution, I takes good care of I. Therefore, I'm left with Now remember the reciprocal law of logarithm, where a negative sign flips the position of the fraction. And one more step. Alright everyone, we've come to the conclusion of today's tutorial. We've been able to prove that this integral is equivalent to this expression. Thank you for spending your time with us in this tutorial. In case if you are having any difficulty or idea you would like to share, you can go ahead in the comment section and express yourself. Meanwhile, you can show me love by hitting that like button. Don't forget to turn on the notifications. Thank you.